In this question here, you're given this tertiary alcohol structure right here. And your goal in this question is you need to figure out how you can make this tertiary alcohol by using a Grignard and some sort of electrophile. So your goal in this is to figure out what Grignard you can use and what electrophile you can use to react with that Grignard in order to form this specific alcohol here. So there's 3 sets of boxes here. 1 box is for the Grignard, 1 box is for the electrophile. The reason there's 3 sets here is because it's kind of giving you a clue that you should be able to come up with 3 different ways that you can make this particular alcohol. And that's the goal here. So what we're going to do is we're really just taking this molecule apart. I'm going to redraw it here. And it is a tertiary alcohol. So we already know that if you use a Grignard on a ketone, it will always form a tertiary alcohol. So we know that our electrophile is going to be 3 different ketones, and we're going to react those ketones with 3 different Grignards, and that'll give us 3 different ways to specifically make this alcohol right here. So our goal is to just take this thing apart. Well, when we look at this structure here, it's a tertiary alcohol. We know that this bond here at one time was the carbon-oxygen double bond of the ketone until something came in and reduced it. So what I'm saying is either this blue bond here, I'm going to draw a blue bond here, either that is the new carbon-carbon bond, I'm going to draw an orange bond here, either that is the new bond, and I'm going to draw a green one here. So this could also be the new carbon-carbon bond. One of those carbons, either this one, let me change that color, either this one, or this one came in and reduced that ketone. So we can take this apart 3 different ways. So let's just go ahead and start with the orange pathway. So what I'm saying is, if that's our new bond, everything to the right side of this dash that I drew here, the side with the oxygen, must have been the ketone. So this whole carbon framework here must have been the ketone. So I'm going to go ahead and draw that in. I'm going to match the colors here as I do this. So we're working on the orange bond. So everything to the right side of that dash, and I'll keep everything sort of drawn the same so we can see that more visually. Everything here must have been this ketone structure right here. Everything to the left side of this, at this carbon right here, must have been the nucleophilic carbon. That means if this carbon was nucleophilic, it's still attached to this 6-carbon ring. This whole thing must have been the Grignard reagent. So at this carbon right here, I'm going to go ahead and put the magnesium bonded to this carbon, and I'm going to pick some sort of halogen there that would actually work for this. So something like, I'm going to draw this up here. So we have our cyclohexane ring. Here's that carbon that's nucleophilic. The magnesium must have been bonded to that. And I'm just randomly choosing chlorine here. You could have chose bromine. You could have chose iodine. But those 2 reagents together, followed by an acidic workup, would specifically make this alcohol structure. Let's do the blue bond now. So if the blue bond is the new bond, I'm going to draw a dash there saying that's the new bond. Everything on the side with the oxygen must have been the ketone. So this whole thing must have been the ketone. This carbon here must have been the nucleophilic carbon that came in and reduced that ketone. So this portion, this 2-carbon portion, must have been from the Grignard reagent. So let's just draw those 2 reagents there. Okay. So everything to that left side of that blue dash must have been the ketone. So this structure here must have been the electrophile we used in order to make this tertiary alcohol, and it must have reacted with the 2-carbon Grignard, which must have been something like CH3CH2 Mg. Let me move this over a bit. I kind of ran out of room. Mg, and I'm just randomly choosing chlorine there. Those 2 things together, followed by an acidic workup, would make this specific alcohol. All right, and now let's do the green one. So if this green one is the new bond, everything on the side with the oxygen must have been the ketone, because that's where the oxygen is. This 3-carbon portion must have been the Grignard, and it must have been nucleophilic at this carbon right there. So let's draw those two possibilities out, those two reagents. Okay, everything above that green dash must have been the ketone. So it must have been this ketone right here. And it must have reacted with a 3-carbon Grignard reagent where the magnesium is bonded to the center carbon. And again, I'm just randomly going to choose bromine, chlorine, or iodine here. That must have been the Grignard reagent that was used to react with this ketone, followed by an acidic workup to specifically make this alcohol right here. So those are 3 possible ways you can make that alcohol using a Grignard and a ketone.